Good day, everyone. Hi, I am Rosemary Tilabasan from BS Ed Math 3A. And in this video, I will show you my geometric model, which is the choreography of Rust in M115 Abstract Algebra. Choreography of Rust is a visual and mathematical meditation on the hidden symmetry of snowflakes. Drawing from a custom 16 elements matrix, each flake is constructed through a series of front and back transformations that echo the step of a silent dance, precise, recursive, and elegant. This model captures the ephemeral beauty of frost in motion, translating cold geometry into warm artistic form. A geometric model based on snowflakes exploring movements, symmetries, and group properties. The model uses a set of transformation and their combinations to determine whether the set forms a mathematical group under the operation defined. And this is our model. In the front of the model, we have elements D, A, Y, L, I, G, H, T. And at the back of our model, we have elements 0, 6, 3, 1, 9, 4, 2, 7. In front of our model, we will use rotations. So we have here 45 degrees, 90 degrees, 135 degrees, 180 degrees, 225 degrees, 270 degrees, 315 degrees, and 360 degrees. And this is the movement in front of our model. T is stay put or do nothing. A, rotate 45 degrees counterclockwise. Y, rotate 90 degrees counterclockwise. L, rotate 135 degrees counterclockwise. I, rotate 180 degrees counterclockwise. G, rotate 225 degrees counterclockwise. H, rotate 270 degrees counterclockwise. And T, rotate 315 degrees counterclockwise. And I will show you how to rotate the given movements. Here, D, stay put or do nothing. And in element A, rotate 45 degrees counterclockwise. By rotating 45 degrees counterclockwise, we come up with letter A. And for element Y, rotate 90 degrees counterclockwise. By rotating 90 degrees counterclockwise, we come up with letter Y. And for letter L, rotate 135 degrees counterclockwise. By rotating it, we come up with letter L. And in letter I, rotate 180 degrees counterclockwise. By rotating 180 degrees counterclockwise, we come up with letter I. For G, rotate 225 degrees counterclockwise. By rotating it by 225 degrees counterclockwise, we come up with letter G. And for element H, rotate 270 degrees counterclockwise. And by rotating it, we come up with letter H. Now, for letter T, rotate 315 degrees counterclockwise. By rotating 315 degrees counterclockwise, we come up with letter T. And at the back of our model, we have line of symmetries. So the broken line here, the blue broken line, represent the vertical axis. And the green broken line here represent the horizontal axis. And the black broken line represents left diagonal. And last, our red broken lines represent right diagonal. And here are the movements at the back of our model. 0, flip vertically. 7, rotate 45 degrees clockwise, then flip vertically. 2, rotate 90 degrees clockwise, then flip vertically. 4, flip right diagonal. 9, flip horizontally. 1. Flip left diagonal. 3. Rotate 90 degrees clockwise, then flip horizontally. Lastly, 6. Rotate 45 degrees counterclockwise, then flip vertically. And I will show you the movements at the back. So, 0, flip vertically. As you can see, after flipping vertically, we come up with letter D. And for 7, rotate 45 degrees clockwise, then flip vertically. Rotate 45 degrees clockwise, then flip vertically. Then we come up with letter A. And for 2, rotate 90 degrees clockwise, then flip vertically. Rotate 90 degrees, then flip vertically. And for element 4, flip right diagonal. We come up with letter H. Then for our 9, flip horizontally. And we come up with letter I. For number 1, flip left diagonal. And the result is letter Y. For number 3, rotate 90 degrees clockwise, then flip horizontally. 90 degrees, then flip horizontally, and we come up with letter H. And for the last 6, rotate 45 degrees counterclockwise, then flip vertically. So then rotate, then flip vertically, and we come up with letter A. And here's the movement of our model from from front to back. And let's have an example. A star H is equal to T. So A and movement to H, which is the rotate 270 degrees counterclockwise, and we come up with the letter T. Next is G star 4. G and the movement of 4 is flip right diagonal. When we flip it with right diagonal, we come up with 0. Then T star 6, the movement of 6 is rotate 45 degrees counterclockwise, then flip vertically. We come up with number 3. And 2 star 9, 9 flip horizontally, we come up with letter H. 1 star I, which I is rotate 180 degrees counterclockwise, we come up with number 7. And 7 star A, which A is rotate 45 degrees counterclockwise, we come up with 0. After following the moves, these are the possible combinations, and we completed the table binary operation star. And task 1, show that the set of moves in your geometric model forms a group structure. So it is closed under binary operations because, as you can see, the resulting elements are all in the set. And to check if the table is associative, we're going to rotate the table 180 degrees. So here's the original table, and after rotating it by 180 degrees, here's the result. After that, the rotated 180 degrees, we're going to do the interchange to make it same as the result of the original table. So here we're going to interchange the rows. As you can see in the column is it's okay, and it's the same in the original table. So we need to do is to interchange the rows. So first is A interchange T, then Y interchange H, and L interchange G. And another one, 0 interchange 3, 7 interchange 1, 2 interchange 9. So we move here. After interchanging the rows, as you can see here, the original table, and if you compare the rotated table and we do the interchange, it's the same. Therefore, it is associative. And now existence of identity element. In finding the identity element, let's look for a row that matches the element in the outer top row. Then we have this row, and look for a column that matches elements in the outer left column. Then we have this column. And the intersection of column and row is the identity element. So the intersection of this row and this column is D. Therefore, the identity element E is D. And the existence of inverse element for all, and we already know that the identity element is letter D. Now we need to determine whether the inverse of each element also exists. So the identity is D. So we will consider element D in finding the inverse of each element. So in finding the inverse, we need to find the row. In this row, we need to find the identity element. And here's the identity element. And we're going to get the top of this identity element, the column, which is the D. So the inverse of D is D. Another one, A, it's the row, and we're going to find the identity element. And let's see the top column, which is T. So the inverse of A is T. We were going to continue doing that. So in Y, we have inverse H. In L, we have inverse. The inverse of L is G. The inverse of I is I itself. The inverse of G is L. The inverse of H is Y. And the inverse of T is A. And the inverse of 0 is 0 itself. 7, the inverse of 7 is 7 itself. 2 inverse, its inverse is 2 also. 4, inverse of 4 is 4. 9, inverse of 9 is 9. Inverse of 1 is 1. And inverse of 3 is 3. And lastly, the inverse of 6 is 6. Therefore, there is an existence of inverse element for all elements in the set. Since all the conditions are satisfied, it is closed under binary operation. It is associative. This identity element exists, and also there's an inverse exists in all elements in the set. Therefore, it is a group. Thank you for listening.